Morning, Doctor and my fellow friend. Now I will explain the first question. The position function of a particle moving in a straight line is s equal 9 over 2t squared plus 3, where t is in the second and s is in the meter. Find the velocity at the particle at t equal 1. So we need to find the velocity at t equal 1. The formula of velocity is change in s over change in t, ds over dt. And for this question, we can use the quotient rule. Derivative of fx times gx minus fx times derivative of gx over gx squared. So the derivative of fx for this question is 0. Gx squared is 2t squared plus 3 minus fx is 9 and derivative of gx is 4t over 2t squared plus 3 squared. So the answer is negative 36t over 2t squared plus 3 squared. Now we need to find where at t equal 1. So t equal 1. So equal negative 36 1 and 2 1 squared plus 3 squared. So equal to negative 36 over 5 squared. So the answer is equal to negative 1.44 meter per x.
For question 2, I wrote all the important information that is needed to solve the question. So first of all, cost per mile. Second, driver salary is $18 per hour. The question is what speed makes 700 mile trip most economical? When we saw most economical, we automatically have the idea which is at minimum cost. So in this question, we will use optimization. Before we start our first order condition, we have to find what is the objective function. So it is given the cost per mile and driver salary is not included in this. So we need to know what is the total cost that makes 700 mile trip most economical, and from there we can find out what speed. So the objective function we can use is total cost. As we say, total cost, this is cost per mile. So we need to times with the 700 miles. So first we times 700 miles, okay? So this one is cost per mile and is not included driver salary. So to count all the total cost, we have to include this into this. So total cost, so we take 700 times cost per mile plus the driver salary, as this function is not included driver salary. So to count the total cost, we have to include it also. So we just take cost per mile, okay, plus this one is $18 per hour. We have to change it to become $18 per mile. So we just take like this. Okay, so we take out our calculator to count it. So this one we can just 700 over 200s, and this one 18 times 700, 12600s. Okay, so 115. This one we can cancel it, so become 7 over 2s. So okay, after we know our objective function, we can do our first order condition, which is x, okay, equals to 0. So this one is this one. So this one is already cancelled, so becomes 7 over 2 plus. We need to move the s to there so that it is easier for us to do. Okay, so this one haven't do, so we just take. Okay, so positive, negative become negative. So before that, we move down. Okay. So to know what is the s, we have to move this towards there. Okay, we need to move this to here. Why? Because we need to know what is the speed. We want to count the speed. So we must make it become s equals to what. So we just move s to here. 7 over 2 here. Okay, so we just take our calculator. Okay. So we move the square to there, become square root. It will become 60. We will only take the positive 60, not negative 60. Why? Because speed cannot be negative. So we just take positive 60 to include in the second order condition. So the second order condition. Okay, so we take from here. Okay, so this one already cancelled it. Become so it will become become positive amount, as negative times negative equals to positive. So 3. Okay, so remove, sorry, this one forgot to write the s. So this one So we just put 60 into this. So equals to, and it is bigger than 0. So it is greater than 0. So from this we can conclude that the cost is when speed equals to 60. That's all. Thank you.
For question 3, we need to find the consumer surplus, but the question only gives the demand and supply functions. So we need to find the equilibrium price and equilibrium quantity. Equilibrium is reached when demand equals supply. Since both the base values are 2, so it can be cancelled out. Solve the equation and we get the equilibrium quantity is 5 and the equilibrium price is 64. To find the consumer surplus, we need to integrate the demand function and minus with the equilibrium quantity times the equilibrium price. For the demand function, we need to use integration by substitution because it is a little bit complex. Let u equal to 11 minus q and differentiate du over dq to find dq, which is negative du. Then, use the rule number 5 to integrate the function. So, we get negative 2 to the power of u over ln 2 and substitute the u back to 11 minus q. Transfer the integral demand function back to the formula and minus with 320. After that, substitute the q with equilibrium quantity, which is 5, and minus with the same function but substitute the q with 0. Calculate the rest and the answer is $2,542 after running off to the nearest $1,000.